SwayamPrabha. Digital India. Educated India.
Hello, welcome back. So, in this lecture, lecture 27, we will be continuing the problem that we were solving in the last lecture. So, I have just drawn the outline of the rectangular cross section. I have omitted the, I have just drawn the center line as we usually do in case of thin wall cross section. So, just for simplicity of the diagram, I have just drawn, I am just drawing the center line. So, I have mentioned the thickness in this green circle across each portion of the cross section. We have found out the centroid, we have found out that XC is located as 36T, and we have also found out that IXX for this cross section is 115,200 TQ, and we have also found out that QS minus Q0, because the cross section is symmetric about x axis is F by IXX and TS into Y into DS. So, we will be having Ts into y into ds. I have written it as Ts instead of T, because unlike most of the examples we have solved, here the thickness is varying in different portions of the cross section. Now, just rewriting what we have derived in the actual in the last lecture, let us now start finding out Qs. Now, let us first start with web. So, let us first assume that consider or assume shear flow at point 1 to be equal to Q0. Okay. So, we say let the shear flow at point 1 is Q0. Now, let us start with flange 1 2. Now, for flange 1 2, so this is going to be our S. This is the S. So, and this is the S, of course. We are moving in this direction. So, we are moving from 1 to towards 2. So, we can say that S is going to be between 60T to 0, and we can write that Q12S minus Q0 is going to be minus F by IXX into TS y ds. Now, we know that Ts is T for the portion 1 2. So, we can write this as Ft by Ixx now y ds. Now, let us see what is going to be y for the portion 1 2. So, we know that y for the portion 1 2 is just going to be 24T, positive 24T. Okay. So, therefore, my Q12S minus Q0 is going to be minus F into y I can replace this by 24t. Therefore, this is going to be minus 24 f t square by Ixx into ds. Now, the integral of ds is just going to be from 0 to s. So, now this is just going to be minus 24 f t square by Ixx into s. This is the expression for q12 that we have. Now, if we try to find out q2, or we can rather also write this as q12s as q0 minus 24 f t square s by Ixx. Now, so let me just highlight this and call it as A. Now, from this expression I can find q2 as q0. In place of s I am going to write 60t. So, this is going to give me q0 minus 1440 f t cube by Ixx. So, this is the expression for q2. Now, once I have found out q2 in terms of q0, I can further write down the find out the shear flow in web 2-3. Now, for web 2-3, my S is going to vary between 48t to 0. And my y is going to be s plus or minus s plus 24t. Now, when s is equal to 0, y is going to be 24t, and when s is going to be 48, y is going to be minus 24t. So, this sounds to be correct. Therefore, we can say that q23s minus q2 is going to be minus ft by Ixx Ts y into ds. Now, this in turn Ts for this section is 3t. So, we can say minus 3f t square by Ixx. Y is going to be minus s plus 24t into ds. Now, if we evaluate this, we can write q23s is going to be q2 minus 3f t square by Ixx, and then we have minus s square by 2 plus 24 ts. Now, if we, so this is the second expression that we get. Let me call this as B. Now, from expression B, we can say that Q3 is therefore Q2 minus 3f t square Ixx. In place of s, I have to mention it as 48. So, if I substitute 48, then we will see, so this is going to be minus 48 t whole square by 2 plus 24 t into 48 t. Now, this is going to cancel out with each other and we will be left with, so from this expression we will get Q3 is basically going to be Q2. So, Q3 is therefore going to be Q2, which is also physically acceptable because we see that the cross section is symmetric about x axis, and because of the symmetry Q2 it has to be equal to Q3 due to symmetry. Now, let us try to find out the shear flow in the portion 3-4. So, let me just erase this off and let me find out the shear flow in portion . So, let me just find out the shear flow for flange 3-4. So, for flange 3-4, S against vary between 60t to 0 and Y is going to be minus 24t. So, if we know that, then we can say Q34S minus Q2 is going to be minus F by Ixx 0 to S ds y ds. Now, in place, so Q34S, this is Q3, so it's going to be Q3. Now, my Ts is T Ft by Ixx into 0 to S minus 24t into ds. This Q3 we know that is going to be equal to Q2. Therefore, this can be written as Q2 plus 24 Ft square by Ixx into S, and that is Q34S. So, this is the expression C that we have. So, let me call this as C. Now, from expression C, we can evaluate Q4 as Q2 and plus 24 Ft square. S is going to be 60t by Ixx. Now, this is going to be Q2 plus 1440 Ft cube by Ixx. Now, from the previous expression, we have seen that Q2 is nothing but Q0 minus 1440 Ft cube by Ixx. Now, if we substitute this into this expression, we will be getting that Q4 is basically equal to Q0, which is also correct due to symmetry. So, we have figured out the shear flow distribution in Q34, Now, let us try to find out the shear flow distribution in the web 4.1. We have also seen that the shear flows at the symmetric points are equal to each other, which also is a way to check that we have done the calculations correctly. Now, let us try to find out for web 4.1. Now, for web 4.1, S is going to vary between 4080 to 0 and Y is going to be S minus 24T, because when S is equal to 0, Y is going to be 24T, and when S is equal to 48, it is going to be plus 24T. Now, if we substitute this, we can write that Q41S minus Q4 is going to be F minus F by IXX into TS into Y ds, which is 0 to S, is going to be, now F is TS is 2T. So, we will have 2FT by IXX into S minus 24T into ds, 0 to S. Now, we know that Q4 is basically Q0. So, we can write Q41S is going to be Q0 minus 2FT by IXX S square by 2 minus 24TS. Now, if we want to find out from this expression what is Q1 again. So, Q1 I have to put S equals to 48T. If we put S equal to 48T, we will see that we find out Q1 equal to Q0. So, we have correctly gone back to the portion Q1 and we have found out Q1 is equal to Q0. So, we have got the expression for Q41 and let me name it as equation D. Therefore, we have found out the shear flow in all the 4 portions of the cross section, but all these shear flows have the expressions for Q0 in them. So, let us now write down the expressions for Q in all the cross sections. So, we have got Q12. So, in summary we can say we can summarize by saying that Q12S is going to be equal to Q0 minus 24 F T square S by IXX. This is equation A. Then we have Q23S as Q2 minus 3F T by IXX minus S square by 2 plus 24 TS. This is Q2 is again Q0 minus 1440 FT cube by IXX minus 3ft so that is equal to Q23S. So this is my equation B. Now we have found out the equation for 3, 4. So equation for 3, 4 is going to be Q34S is again going to be equal to Q2 plus 24 which is equal to Q0 . So this is my equation C. And similarly, we have found out Q41 to be equal to Q0 minus 2ft by Ixx So this is my equation D. Now, if on all these 4 equations that we have to apply Brad-Pethos theorem. And we have to say that Qs by Ts into ds is going to be equal to 0, since there is no torsion. Now, let us try to evaluate this integral and see how we can evaluate this integral. So, this integral therefore is going, so Qs by Ts into ds is going to be 0 to 60t Q1 to S. Now, the thickness of that is T into ds. Then we will have 0 to 48t Q23S by 3t into ds plus 0 to 60t Q34S by t into ds plus 0 to 48t Q41S by 2t into ds, and that is going to be equal to 0. So, this one is for flange 1, 2, this one is for flange 2, 3, this is for flange 3, 4, and this is for flange 4, 1. Now, if we evaluate this integral, all this is going to have a Q0 in them. All this have a Q0 in them, as you can see from expression A, B, C, D. So, therefore, this whole expression therefore can be, so everyone has a Q0 in them. So, we can write this expression as, so Q0 into the total circumferential length, that is Q0 into 2 into 60 T, which will be divided by T plus 48 T, which is going to be divided by 3 T plus 48 T, which is going to divided by 2 T. So, this part is going to be there for every one of them, plus we will have an 1440 T for Q23 and Q34. So, we will have minus 1440 F T cube by IXX into, so this is for portion 2-3, which has a thickness of 3 T. So, divided by 3 T into 48 T, and then we have another 1400 F T cube, which is for portion 3-4, which has a thickness of T into 60 T. So, these are the two other expressions that we have. Sorry, these are the two other expressions that we have. Then we have to just take integral of the remaining portion. So, out of the remaining portion, we can actually take out F T by IXX, and then we can write this as 0 to 48 T, which is going to be 24 Ts by T into ds. So, this is for this is coming from portion 1 2. Then we will have, sorry, this is 0 to 60 T. So, this is 0 to 60 T. Then we will have 0 to 48 T, and that is going to be minus 3 T. So, this is also minus 3 T by 3 T, that is the thickness, into minus S square, or I will just write it in a separate portion. Zero to 48 T minus 3 by 3 T into minus S square by 2 plus 24 Ts into ds, and so on. I am not completing the entire expression because it is very lengthy, and then this whole expression can be actually equated to 0, and this whole thing can be equated to 0, and this will give us the solution for Q0. So, once we find out the solution for Q0, we can substitute back into, so we can substitute Q0 here, Q0 here, and get the entire shear flow in the cross section. So, this is the process that one has to use to find out the shear flow in a closed cross section beam. So, this is a very lengthy process, no doubt, but this is the only process that can be adopted to find out the shear flow in the cross section. In the next lectures, we will solve certain more examples to get a better clarity and better understanding of the theory that we have discussed. Thank you.